good evening, and welcome to the 14th edition of Better AI Meetup here in Bratislava. I'm very glad to meet you on behalf of the co-organizers, which is HubHub, Kinit, and Innovatrics. And we are actually starting our 4th year of these meetups, and I'm quite glad that this is quite full, because when we started out, there was nobody here in front of me. I was speaking to the empty audience because it was COVID, and everybody was responsible and socially distanced. So I'm quite glad that now we can speak to the actual people here live and also online. Apart from being the 4th year of Better AI Meetup, we are also presenting the 2nd year of AI Awards, which are given to trustworthy AI companies and their research and development teams in Slovakia. There's still 2 more weeks to apply. You can apply until the end of February this year at aiawards.sk. And apart from Kinit, who is co-organizing it, it's organized by Hopero, and the Committee on Ethics and Regulation of Artificial Intelligence will be also. So there are all of the third-party independent jurors who will be checking out your AI code. So you are welcome, and apart from being awarded as the best AI solution of the year, you'll also have a chance to participate in Better AI Meetup, because we had all the finalists here last year. So don't forget to apply if you haven't already. We are also supported by Slovak diaspora, which is the Slovak scientists who are working abroad. And one of them will be here having the very first presentation. So let me welcome Pavol Bielik from Lattice AI, from the Swiss company that's actually started by a Slovak guy. So Pavol, here the floor is yours.
Okay, well, thanks everybody. I'm excited to be here. My name is Pavol, and what I would like to tell you today a bit more is about our path that we kind of went through in last, I think actually more than 5 years, but more intensively in the last year, from kind of high-level AI regulations to technical compliance. And kind of funnily enough, maybe the first thing I will tell you is actually forget about AI regulation and forget about compliance, but maybe think about it from the perspective of what are the internal risks or just best practices of using AI, and how do you achieve technical excellence. And both of these are kind of the same, or like different sides of the same coin, where on one hand there is someone knocking on your door saying, hey, I'm a regulator, like tell me, did you comply with all the things that we put up? Whereas the other one is the internal, like, are we building it in the right way? Are we building it in a way that we can afford internally to scale and just be efficient? And the way kind of we always think about it is kind of the journey of AI starts with the data, and then goes into building the model, evaluating the system, and deploying and kind of maintaining in the production. And at every part of the step, there are different challenges that companies might face. So if you look at the data and kind of think of what can go wrong, often you would see things like, well, if I don't have enough data quality, and now data quality might mean 50 different things, and that's part of the challenge, but let's assume if the data quality is not high, what is the effect for my company, for my business? And that effect can be very large. So this is a recent example from some of the published papers that shows essentially the same model trained on different data can kind of range all the way from -12 to -50% performance degradation. The same thing happens with when you deploy the model and you evaluate it. So imagine you have a model, it has like 99% accuracy, but I would tell you, hey, there is a region of your model. So imagine here, like each little point is one particular sample or a prompt or a user in your data set. And I would tell you, okay, on average is 99%, but in this small region here, the performance drops to 10%, right? And when we talk about compliance or kind of safety critical applications, it's really not about the average use case. It's all about the edge cases and what can go wrong and being very thorough and kind of looking at them. The same thing with kind of the general evaluation of the system. So often you deploy the system kind of internally, almost in a lab environment. You deploy it to a new client and kind of you often kind of pray that things will go well and things will not degrade. And in the same way, when you deploy the model, you are getting lots and lots of new data. And now the question is, how do you manage this process efficiently? So maybe all of this data, 99% I don't need. Maybe I need this like 1% of the data that is really important to include back in the cycle to make good decisions in the end. So this is kind of why I said it's on one hand also about regulatory compliance, but also just about technical excellence. And today, what I would like to tell you more is kind of two concrete projects we did in the last year in this area. So for the first one, we did kind of assessment of what we call traditional AI system now, which is maybe not so cool anymore, which is essentially a regression system used to essentially price cars. So this is one. And then the other one, which will follow the same principles and challenges, but is now applied to general purpose AI systems and is affected by the new European legislation from the EU AI Act. Okay, so let's jump into it. And kind of why are we doing all these things? Well, on one hand, this is in all the news now. So some of you went, for example, last week to the AI Summit in Paris, where this was kind of discussed at length. 3 weeks ago, there was also kind of all the world leaders met in Davos for the World Economic Forum, where for the second row now, the AI risks and trust has been the top one priority worldwide. Also according to the Gartner. And in many ways, the reason is, well, ultimately, many of the companies now face these challenges with especially the new wave of the Gen AI models that bring a lot of new challenges, whether it's kind of legal risks, business risks, or reputation risk. And one thing that is becoming more clear and clear is that these are not only risks that are kind of disjoint from the company. And it's kind of very clear that when you want to manage them, you kind of need some way to kind of start and have a holistic approach. Okay, if I have this new system, what are the risks in the first place? How would I measure them? How would I mitigate them? And ultimately either comply or with internal or external regulations. And one thing that is becoming very clear is that this is really a problem of companies who deploy these models are becoming responsible if something goes wrong, right? So it's not like, oh, there is this external company, they provided me the system, it breaks, it's not my problem. No, it's my problem now. And especially so when it becomes about cybersecurity. So this is just an example from the recent news where kind of the kind of chief information security officers admit that essentially 1/5 of the big enterprise companies leaked confidential data to these like public chatbots. And some of them has even had to be completely shut because it just kind of went out of rails, not only internally, like in this case, this was essentially a system that started telling other users confidential information of other clients, right? So clearly not something you want. Okay, and the main challenge here, again, kind of maybe from the perspective of how do we approach these things is that it's not really, I mean, in one way it's cybersecurity, but in other ways this is just normal usage of the systems. Just because they became so powerful, these are like new problems we have to deal with. We're kind of trying to put guardrails around them. So let's kind of jump into the concrete details. And I will start with the traditional use case, and then we'll move into comply, which handles the generative use case. So for this one, just to give you a bit of context, so the setup is the following. So there is on one hand, kind of car leasing company that are based in Switzerland, and essentially their whole business is I can predict the price of a car in 3 years better than my competitors. So this is their main business. So you go, they say this is the car. It initially costed, I don't know, 61,000, and we can rent it for you with some monthly payments, and after 3 years, it will cost 23,000, and this is guaranteed, and we will essentially buy it for you for this money. Now, we can imagine their competitive advantage is that their prediction is better than the competitors, who were doing it kind of based on these big Excel spreadsheets that were not really kind of data-driven. But naturally, if they're wrong in 3 years, they are going to have a lot of issues. And the problem of the Migros is that they're financing all this business. So by kind of definition, if they're wrong, then Migros is going to lose a lot of money in 3 years. So this is kind of the whole setup, and now it's data-driven. So all this model is based on, let's scrape a lot of data from the web, from like all the car leasing resellers, maybe from different providers, and essentially put a machine learning model on top to kind of make this prediction. And the process has kind of 2 dimensions and several steps. So the high-level dimension is, on one hand, there is a business layer. So the business layer is, there are some regulations, best practices that we want to check, and ultimately, we want to address business impact. And this is, again, imagine this is a chief risk officer who would essentially be reading this report and making decisions of, like, do we need to reserve more money in the bank in case something bad happens? What is the likelihood of this other company going bankrupt and so on? And on the other hand, there is a technical layer, meaning, okay, well, we have the data, we have the model. How is the data good? Is the model good? Does it have these kind of systematic mistakes, which would ultimately result in a bunch of numbers? And as you can imagine, the people reading this report, if you tell them 13% of the features have missing value, they will have no clue, like, what does this even mean? And should it be 5%? Should it be 50%? I don't know. So let's see kind of what are the main challenges. So the first one is you kind of have to go deep, right? So because, or at least what we've been traditionally focused is doing technical assessments, you don't want to make these kind of conclusions based off, oh, someone told me they have a good model, and someone told me they cleaned the data. So this is not what we want to do. We want to, first of all, formalize what does it mean. So as I mentioned, data quality, let's actually write it down. Let's write it down. Data quality, it has these 20 dimensions. This is what it means. And let's see what you actually did, and in which dimension does it fit. So kind of that's the first step. And the main challenge in this, if you want to connect it to the regulations, is that when you start reading the regulations, you will very quickly realize this is extremely, extremely hard. And maybe for a good purpose, because the way many of the regulations and standards are written is at a very, very high level and an abstract level. So just to give you a very concrete example. So one of the data quality metric is relevance. And if you read the standard, to see what is a relevance, it's defined as the ratio of records in the data set that are relevant. Well, this clearly didn't tell me much, right? So great, like it's some division of A over B, but like I cannot do anything with this, right? So this is just one example of at the level of which the standards are. Another example is, and I already mentioned it on the previous slide, is feature completeness, which again, okay, like maybe this is now slightly better defined, which is the ratio of data items that don't have null values. So in their case, this would be car leasing companies, so I get a car. So like, do I know the number of kilometers driven or the engine? Do I have this value or is it not there? So I can clearly compute it. The problem is, what do I do with this number? So great, it's 20%. Didn't help me either. And again, it would be things like representativeness. So is my data representative of the real usage? Again, maybe not its definition, but I really don't know what to do with this, actually any of this. And the main thing that is completely missing from all this regulation is this connection of, okay, I have the data, I have the model, but what's actually the connection between them, right? So the question is not really like how many features are missing, but how does missing features affect my model performance in the downstream task? And if that effect is higher than some value, then I actually care about. The same for representativeness. So it's not about my representativeness is 0.5. typically the kind of hypothesis here is that if the data is not representative, something bad will happen. Maybe the system is biased, maybe the performance degrades, and this is where the connection has to be made. Not to mention that you have these kind of ambiguous incomplete definitions, but you don't only have one, you have like 15 of them. So again, good luck kind of trying to formalize this. So kind of main thing we had to do as part of this process is to actually review this and come up with a formal definition of all these things. That is not only something that we can actually measure, we can explain to other people, and we can connect it with the downstream model performance. And just a very kind of concrete example, which is also like, why is this kind of technically challenging? So imagine now we talk about representativeness. So let's try to visualize it together. So here, I can have this view where each of these small little points is a sample in my data set. And now imagine they're kind of put in this space based on some notion of similarity, right? And then this is the data used in the training, and then these are the questions I can start asking. So what is the data in my test data set that is actually similar to the training? And now I see that, okay, there are a couple of points that appeared here, seems good. But now maybe I have a data in the test set that is actually completely in a different region on the data distribution from what I train on. It might be good, might be actually exactly what I want, because if I care about model generalization, I should not only train here, because if a new example comes here, then clearly this is not something I train about. But now I have a way to kind of, first of all, measure and define what is my expected outcome. And, for example, does my model performance degrade here or not? And if yes, that's a problem. And the same thing you can do on unlabeled data. So if I unlabel data again, maybe something matches the training, maybe something matches what I had in the test that didn't match the training, or there's, again, something completely new that I didn't see neither in the training, neither in the test. And the final step is this kind of lifting of the kind of interpretation to something that ultimately can be written as, is this critical? How much money am I going to lose? And is it something I really have to fix tomorrow? And this does require kind of business discussion with the stakeholders that is a challenging process here. So kind of ultimately, to conclude this part, you kind of go through this process of setting the requirements, formalizing them, measuring them. And I think the main important fact, not only for us, but also for the companies we worked with, is that you can go back, essentially. So you can read this, and you can actually understand some of the things, and then you can apply them back to the system. So this is kind of one part. And the second part, at the high level, will literally follow the same process. The difference will be the requirements are different. So there is now EUA Act. It has like lots of pages that you have to read, parse, come out with the requirements. The formalization is different because it doesn't kind of talk about, I mean, it still talks about representativeness, but you have other requirements that don't apply to regression systems. So what did we actually do? So this is kind of, if you open the website, and by the way, I encourage everybody, this is an open source project, so everybody can go, actually download it and run the assessment and see the results. So if you go on the website, we did kind of two main things. So one is this kind of mapping and technical interpretation of the EUA Act to what are the technical principles and what do we actually want to measure. And the second part is also the implementation, because if you would stop here, that's still kind of in the paper or on the paper. Like, okay, I still cannot measure anything in Automate, so this is now a GitHub repository that you can essentially run. And kind of if you go through the process, so in this case, start with the EUA Act, you first have this kind of 6 high-level principles around which the EUA Act is built upon, which include things like technical robustness, transparency, but also things like human oversight, non-discrimination, or just social and environmental well-being. And you, again, want to be very precise. So you literally go to the level of Article 15, Paragraph 1. What does it concretely say about model accuracy, robustness, and cybersecurity? Or what does Article 53 say about copyright? What are the copyright requirements when I train the model with some data, as well as when the model produces some data and I want to use them as an output? So what should I do? These are now the technical requirements, and if you kind of go through this process, there are kind of 14, again, very high-level technical requirements. If you look here, this is, again, the language they use, appropriate level, without actually specifying what is the measure and what is that appropriate level. And then this is the second part that says, OK, well, now I have all these technical requirements. Now I have essentially a benchmarking suite that maps to those requirements. So for example, for copyright infringement, we do focus on the technical part. So naturally, there will be things that will be on the legal side of what you have to do when you have to deal with copyright. On the technical side, there will be now a check that says, OK, if you give me a chatbot or general purpose AI system, how can I probe it in a way to check if it was trained on copyrighted material? Right? And now I have a check that I can run, and it will tell me kind of to what degree does this happen. And similar for other benchmarks. So this is kind of the high-level idea. Ultimately, what you get on one hand is a report, and you can also generate your own if you would like. And this is visualized on the website. There is kind of different categories. We also have this kind of high-level score. And there is also a leaderboard on the left. One important thing I would like to say is, like, especially when it comes to EU Act and compliance, like thinking about it in terms of leaderboard is a bit misleading, because it's not like who is better or who is worse. Like it's these are the requirements, and we want to satisfy them, and kind of all together we want to work to make it better. But there is a leaderboard, and like if you talk to media, this is kind of thing that they, for example, like, because then they can rank things and say this OpenAI is better than someone else or worse, and so on. Just to keep in mind. So when we release this, naturally, I mean, not naturally, but given there is a lot of talk, we also received a lot of feedback, and I think this is very important. Again, one thing I want to make clear, and you've probably seen it from the presentation, we really do focus on the technical aspects. So we try to be very comprehensive on that level, but this is by no means something that we could claim this is a complete compliance and certification process for EU Act. So this is clearly not the case. So once we did this, then the next step naturally is, OK, let's take what are the models that exist, and let's actually try to evaluate them. And for this, we try to take the kind of most popular and used ones. But we also work with kind of more research models or local communities. I have just two examples here. BGGPT is a kind of Bulgarian national model that they trained there. And here, Speaklish, by the way, which has the same name as me, so it's called Bielik. It's a Polish model, so it's a Polish national model. So we also evaluated those. Whenever there is a Slovak model, we would be also happy to kind of look at that as well. So what can we see here? So this is kind of a summary of some of the findings. On this side, you can see like all the versions of different models that we looked at, and this is, there are by now quite a few more on the website, so this is kind of state as of like, I think November last year. And on the y-axis, these are kind of these different technical requirements that kind of put together different things, like for example, how interpretable is the model, what are the capabilities, what is the resilience to cyber attacks, and so on. And then we can kind of start looking at the individual numbers. We try to normalize it to a degree. Again, this is not a formal compliance, so one doesn't mean you are going to get a stamp from European Union. This is just our interpretation. So again, kind of the main thing is 1 is good, 0 is not so good. And some things, for example, cannot be evaluated. So this is also true because we have different technical requirements. For example, if you evaluate, is your data that is used to train the model biased? Clearly, you need access to the training data. And now good luck going to OpenAI and asking them, please send me your data to check for bias. So this is not going to be possible. So what are some of the interesting findings? So if you look at kind of harmful content and toxicity, one thing that we can see, so in general, this is something that pretty much all models do fairly well. And one of the reasons is that kind of in the research world or also in the industry, there are, for example, existing benchmarks to test this. So this is something that is a dimension that many of the companies already consider and have some mitigation strategies against this, which is also reflected here. So this is kind of relatively good. There are other things that maybe don't work as well. And this is an interesting one here, where there is now a clear differentiation between commercially aligned closed models and publicly aligned models, which is also understandable. So if there is a research group that is developing a model, maybe cybersecurity is not their main concern. Another one is, so if you look actually here, I said like we should not really look at it as a leaderboard, but actually the models here are ranked using the overall score. So like to some degree, they should be the best, they should be the worst. But one thing that is also clear here is that, again, this ranking, and that's what's interesting here, is not necessarily aligned with like the downstream capabilities of the model. So maybe I have a very good model here that, for example, helps me better summarize my documents or better answer my questions against the knowledge base. But in all the other categories, it's actually much, much worse. And that's why it ranks low overall. Similarity for robustness. So here there is also like a clear correlation between how big the models are. So if you have really big models, they tend to be much more robust than the small ones. And then also for some of the benchmarks, so this is essentially, especially for fairness and discrimination, what we see, at least the current version of the benchmarks, is not really good at differentiating the models. So they all kind of perform fairly similarly, not that great. So this is like an open area of work that more time needs to be invested in to come up with better benchmarks and better evaluations. If you're interested, all of this is, as I mentioned, it's open source, it's available. There is also a technical report that kind of summarizes some of the things that we did, why we did them, and how to use them. And with that, thanks a lot, and I will be happy to take questions a bit later.
Thank you, Pavol. Thank you a lot. I believe there will be a lot of questions because I remember that our part on AI Act was actually one of the most watched and restreamed. So I expect a lot of questions after the second presentation we will have now, because as you have seen, there's a lot of theory and standards behind the testing, but there's also practice, the fun part, which is the one that you are here for. And Igor Janos, my former colleague from Innovatrics, he's a head of R&D there. He will introduce you to an approach how to actually get touchless fingerprints through your smartphone to be comparable to normal fingerprints. And it was quite fun because I was participating in it, so I even had my fingers cast in the gypsum. But he will tell you much more in detail. So Igor, please, welcome.
So, thank you, Jonas. I'm very happy to be here with you today. And I will tell you something about this little project that we have been working on. And it's about contactless fingerprints. So, why are contactless fingerprints an issue? During the COVID era, many people were concerned with touching something. So, if there is a way to acquire your biometric sample without you touching anything, that's really a good thing. And also, another benefit of contactless fingerprints is that there is actually a lot richer information if you take a look at your finger as a 3D object, because if you make an impression, then you kind of discard a lot of information since this is only a 2D impression. So now we have these specialized scanners, like the one you can see on this image, that are developed specifically for capturing contactless fingerprints, but these are kind of expensive, and this is special equipment, and you have to work with it in kind of controlled conditions. So on one level, this is really good. On another level, there is another use case that you can do, and that is just using your phone. And you can do that anywhere. You don't need any kind of special equipment. Basically, anyone can do it. But the problem is acquiring images with your smartphone is largely inaccurate. There was a study performed by the NIST in 2020 or 2021, and they have analyzed several devices, several vendors, several algorithms, and they have found out that the false rejection rates were somewhere about 75% if you were using an image from your camera, compared to maybe some 5 or so % when you use such a device like the one you can see. So, what are use cases where you might consider using such a technology? As I have also mentioned, you don't need any special equipment if you can use just your smartphone, but there are also some nice applications of it, like if you want to apply for visa, you can just take a picture of your finger. That would be great. Or maybe in law enforcement, there was a nice use case in America where policemen try to acquire images from mentally handicapped people, and this is really difficult for them. It's really unpleasant if you are to be held against your will and someone is forcing your hand somewhere. This is really very bad. So if there is a way that you can just take a picture and be sure to some degree that this person is not in your wanted list, that's really good. But what is the problem? There are many compatibility issues with contact-based and contactless systems because, as I have mentioned, we lose a lot of information. We get rid of the third dimension. When we make a 2D impression, we only get partial information from your fingers. Also, sometimes you put too much pressure, sometimes you put too little pressure, so the finger looks always different. And you can see on this video that if you press your finger against the surface, it will change its shape. It will deform, and all those tiny minutia points, they will move around, so these images look differently. If you just take a picture and make a contact-based impression, these are two completely different things. So, what we were about to do was develop a special neural network, a special algorithm that will do a contactless translation. So you just take a photograph of your finger and it will try to convert it to a regular 2D impression. And by doing so, our model needs to be able to handle these three problems. First is it needs to account for different lighting conditions. So maybe there's too much light on one side or another. If you take a look at your finger from different sides, it needs to estimate the point of contact because you know what part of the finger is actually touching the surface, and also how much of the finger is actually visible, because we cannot use all the information that you can see in the picture. And last is the way how the finger is deformed. Okay, so this is the most important issue, because if we don't account for the skin deformation, then those fingers, they will not match. Okay, so now what we were about to do, we have approached this mainly as a data problem. So we have decided to put our bets on synthetic data, and we try to simulate the entire process of how fingerprints are captured. So we started with obtaining 3D models of real fingers. Then we try to synthesize artificial ridges. Then we try to model these fingers as a soft body simulation. So there was some physics involved in this. And finally, we did some randomizing of the lighting, and this was all very fun. And as you can see, at the beginning of this project, everyone was smiling. This was people walking around like, what are you guys doing? Oh, this is such great, I want to do it too. So everyone just chipped in and put their fingers into our little cups there, and we were making 3D casts of our fingers. So this is what we got. 16 models, 8 female, 8 male. And once we got this, then we did 3D scanning. And the funny part is that we did not use any special equipment. This was done by cell phones. So this is actually the level of technology that exists today. So once we 3D scanned our fingers, we got these incredibly detailed 3D models. The mesh actually contains several 100,000 vertices, so all the fine details, it's preserved in there. It's not a texture, it's really the 3D mesh that has the details in it. So once we got these, then we had to rig these models with some bones so we could position them just the right way we needed. And then, of course, we had to get rid of all these fine details because we needed to replace it with some patterns of our own, okay? And this was, again, an interesting problem because we originally thought that we will use rolled fingerprints of real people. We had collected some of them, so we are considering that, but this was a problem because these rolled fingerprints, they typically contain holes, so you cannot do really good model. Another problem is the level of detail, because if we have like 500 dpi finger impressions, it's not good enough to do 3D modeling and lighting and such. So then we decided for a completely synthetic pattern, and this is interesting because this is basically a spiral distorted with several randomly placed minutia points. And even though it's not perfectly real, it looks real enough on the finger, okay? And another great benefit of this is that this pattern is expressed as analytical function. So we can render it in any detail we need, and it can be computed on GPU shader in no time. So we can really play around with it. We have also explored several ways how to model the ridges, so this was very nice to have. So once we did this, then we have tried to model and display our fingers. And as you can see, this is what we got, and this basically looks just like the real fingers, because sometimes there is no ridge pattern visible. Sometimes when you move the light around, only different part of the image is visible, and this is what happens with real fingers. So, yeah. Another issue is that skin is, of course, not completely opaque, and it absorbs lights and scatters the lights beneath. So this was again something that we had to model, and this gives again just a little more touch to the fingers of feeling more real. Okay, the next was the issue of lighting, and this is what we did. To do correct lighting, we need, of course, the normal maps that will give us that will help us calculate the way how the light is reflected from surface. And this can be done as a derivative of the height map. Originally, we have considered using the rolled fingerprint, but this was not detailed enough, and this is where our synthetic pattern really shines. So you can see on this animation that now we have a 3D model of the finger. We have removed all the fine details from the original ridge structure, and we have replaced it with an artificial one. And we can change it in real time. We can sample all these values from random distributions, and this is important for us because we don't know what the right values are, and we can play around and generate different batches with different properties, okay? So then there was the question of skin deformation, and we have approximated the surface of the finger with a system of mass particles, and we have modeled the forces between them. So we were able to simulate how the finger would look like if it were pressed against a flat surface. And as you can see, this is quite nice, actually. We are able also to play around with how much of the finger gets imprinted on the scanner, what is the cutoff and fall-off rate, and stuff like that. So once we got all of this put together, then we began rendering our data. And this is a demonstration of the process. So you can notice that we had our little stick down there, and the rest of the finger was affected by gravity, and also there was the lighting being randomized, and there was this flat surface, which was kind of a camera. And we have made 2 snapshots. One is when there is the most contact, and one is when there is the last contact. And this way we were able to synthesize as much data as we need. Okay, now we can move on to our model, because this was also important, and we have considered several approaches. The first was to use a standard unit architecture. Yeah, boring, but why not? So we started with it, and this was really difficult. This was like several months of frustration where nothing seems to be working. And the problem was that this model was not able to understand the deformation, okay? So after like a month or 2, we have gave up, and we have decided, okay, let's try to avoid or abandon the skin deformation altogether, and we will just focus on capturing the light and handling the light. So we have trained one such model. Later, we came up with another approach, and this one consists of 2 modules. The first is the displacement module, the second is the translation module, and the idea was that we can actually force the network to really concentrate on just moving things around. You maybe have heard about the spatial transformer paper. It has been around for like 10 years, so that's not a new idea. But the idea is that we can have one module predict the way how parts of the image are displaced. And then another module will resample the images or features based on the displacement features and translate them. So by cleverly balancing and making this translation module very, very small, we are forcing the network to really learn how things move around. Because the idea is, if the displacement module does its job right, the translation module has a very easy thing to do. It just needs to copy the input to output. And this was also trained in an adversarial way. So we had a discriminator, and there were also other restrictions, because this displacement, it cannot be just random. It needs to have some consistent shape, like in the animations that I have shown you before. And this really helped. And once we did this, we focused on evaluating. So we have collected validation data, and this was done by several devices. We have 2 actually. One was a rather high-end device, a modern iPhone, and another was an old Xiaomi device. And we have collected 250 unique fingers and used a background gallery of 10,000 images. What is really interesting about our approach is the way that we have trained the entire pipeline, because as you can imagine, there are quite lots of unknowns, like just the hyperparameters of how we train the translation model, and also the parameters of our data, because we don't know what is the right reach density. We don't know what lighting should we use, or how much wide the field of view should be, and stuff like that. So we have made such a pipeline that we will generate batches of 5,000 images. We'll generate several of them, and then we will train the translation model for a while. Then we will evaluate it and select those batches that give us best results. Then we will adjust the parameters of the synthetic data and generate a new batch or a new set of batches. And then we will continue this process until we will arrive to a model that scores best on the evaluation metrics. Because the evaluation metrics, they are not something that you can see during the training, because this is like, a GAN training, so there are other metrics. But this was the way that worked. And I can show you some interesting results. These evaluations contain also this red graph, this was one of our partners that we have worked a few years ago, and this C3K company was one of the contenders of the original NIST report. So they have scored on shared third place, so they were very, very successful in what they did, but their algorithm was based purely on image processing. So basically they did contrast adjustments, brightness adjustments, and stuff like that. And we can see that our models are quite a lot better. The original error rate of the T3K algorithm was about 60 or even higher on the low-end devices. These error rates are consistent with the original NIST report. And as you can see, down here there are two models, two of our best models. This first one is the original unit, that one that was trained without the skin deformation. So we can see that clearly just by understanding how the light works helps a lot. This is significant improvement from 60 to 45%. And this module down there, that's the one that also understands how the deformations work. So in these results, you can see all devices. I would point out that the Xiaomi was a troublemaker, and if we look at just the Xiaomi samples, then these numbers are actually a lot higher. I think it is understandable if you want to do fingerprint recognition, you need to use good camera, okay? But if we take a look at the images made from iPhone, the difference is quite remarkable. Actually, these numbers, they are almost approaching the error rates from the special devices that I have shown you before, the static mount special scanners. So this is quite interesting, and to me it's quite remarkable because these models, they have never seen a single real fingers. They were just trained on purely synthetic data, and there were quite a lot of shortcuts. So this gives us hope that we can actually make this into a nice product. We are working on this. So then we will have maybe next couple of months something ready. And yeah. So thank you, and I will be happy to answer your questions shortly.
Thank you, Igor. If you have any questions here, you can just use Slido, slide.do, and use hashtag #better_AI, and you can pose any questions. We will be talking specifically with Pavol in our next Q&A session, but you can also have questions for Igor, and he will be happy to answer them. As you can see, he's very enthusiastic about the research, and he knows them too. So he was when he was researching this, he was usually sending me, the videos that were currently in development, and I usually opened it during a meeting, and there was just big finger moving around. So the moral of the story is don't open chat during meetings. So yeah, so I'll now invite Pavol, and don't forget to post your questions on hashtag #better_AI, and we'll get to the Q&A. Okay, so before we get to the questions, we have some at the start. So how fast are you actually able to adapt your models to the changing regulations? Because you've shown that you have quite robust set of rules and examples.
Yeah, this is an interesting question because, the approach we are making it's essentially separate layers. There is a wider layer of the technical requirements that are essentially almost separate from the regulations. That's why I said this is also what we were doing before, some of the strict regulations were there. This is just what does it mean for the data to be representative. This is how I evaluate models. This is how I find blind spots. And they have a parameterization. So essentially when a new regulation comes in, it's an exercise of reading the regulation and kind of mapping it to existing checks that already exist. Because it's not like you have new checks every day. So these things are relatively standard. The hard part is really to formalize it and make sure that you have enough flexibility to adjust it.
And You know, when we are talking about regulations, and I mean, when you were analyzing, you know, all the, I mean, you mentioned the definitions and everything. Did you find some parts when it was actually contradictory? So it didn't.
Yes. Yes, I mean.
And how to solve that? I mean, because this is something that you encounter. I mean, you know, this is like a real business problem. Apart from the fact that it's funny, you know, it's like a real business problem because you have to fulfill like both part of the contradictory regulation.
Yes, I mean that's why I also mentioned like there is a reason why many of the regulations are very high level because they try to avoid this problem. It's essentially, let's not go into the details such that we are not essentially shooting ourselves in the feet. The main way to avoid this is you just make your own interpretation. And I mean, the main thing here is kind of maybe to explain like how the certification really works. Like the certification works by interpreting the standard and by having a companies, could be like the Big Four, KPMG and others, could be like some national institute that is required. They would then take the regulation, they would take it your interpretation, and they would then make essentially give you a stamp or not based on whether does this make sense. So if you come with them and says, hey, look, the regulation in the current version actually is contradicting, this is why and this is what we did instead, I mean, they are reasonable people, and then ideally they fix the regulation in the next revision.
Where do you see like the most interest from to actually comply with the standard, or I mean for your assessment? I mean, you shown the example of the bank that was actually doing the leasing, but what are maybe the other industries and sectors where there is interest of such evaluation?
As I mentioned, I think banks are a good example because banks are already highly regulated. So for them, this comes very naturally. They already have a process internally for kind of governance across the company. Now they're essentially extending it with, okay, how do I plug in AI into that governance framework? And one interesting thing that happened in this process is that they kind of realized that, okay, I actually need the central registry of like all the AI system across the bank, because it's not only things that kind of I'm developing my own AI. Like now, if you open Microsoft Word, suddenly there is an AI feature there. Like all the products have an AI feature, so they have to kind of handle like, how do I deal with all of this? So I think this is the natural one. Kind of coming from Switzerland pharma, it's also kind of up there.
Of course.
Because they're also highly regulated. And then for the other ones, I think this is where it's kind of more about less of a compliance, at least yet, and more about kind of how do I build it in the right way. So, I mean, we also had the example from Innovatrics. So this is an example where there are some regulations, but they would, for example, not go into the depth that would require, at least legally, such a formal assessment.
And if we talk about the financial sector, because I fully see why they are maybe the most interested, or maybe, let's say, the most prepared, as you said, is there any difference for the evaluation between, let's say, models which are hosted on cloud and models which are hosted locally? Because that was one of the discussions last time when we had the banking people here, that, you know, they do a lot of their modeling actually locally without,
yes,
you know.
Yes, that's pretty much a hard requirement. Like nothing lives out, everything is in a sandbox, everything is offline, yeah.
Okay, so that's fine. Could you elaborate on how you measure the interpretability of the models? I was surprised to see the values for OpenAI models, unlike the NA for Claude. The interpretability of the models, that was one of the sets of ratings.
Yes, I'm trying to remember. So the NA, as I mentioned, so there are some technical requirements on running the benchmarks. And some can be also on our side. Like sometimes we just cannot evaluate it because we cannot kind of deploy it. The main one here is for interpretability, and specifically, you can evaluate models in this black box manner. So these are chatbots or GPI systems. So you give it a prompt, and you kind of get an answer, and then you can check if it's correct or not. For interpretability, things you would want additionally is, for example, what is the probability of the next token, and then you would be kind of checking, like, is that probability in the right range, or like, does the model has the right bias with respect to this set of words or this other set of words. I mean, for this one specifically, interpretability, I actually don't remember at this point, so I would have to look it up. What exactly was the benchmark there?
Yeah, we can mention it in the mailing afterwards. So, are we sentenced to endless creation of a new benchmark because of the data leaks?
That's a very good question. So, just last week actually, we spoke with Peter Madsen. So Peter Madsen, he's the CEO of ML Commons. So this is a large non-profit organization in Europe focused on benchmarking. So they traditionally did lots of benchmark in the space of, for example, performance. And now they also released a new benchmark called AI Illuminate that is specifically targeting harmful content that this kind of Gen AI system can generate. So they have multiple categories like sexual abuse, harmful content like do I want to like overdose myself, and things like this. And their approach is essentially they have a part of the data set that is public because you need to have transparency. So I cannot come up with a private benchmark that I will tell you, I don't tell anybody what's inside, I will just give you the score because then everybody will like, okay, like how do I trust this benchmark? So they have a part of it that is public, it's 50%, and then they have a part of it that is private. And not only it's private, they are like rotating it over time. So for example, they have a version now, they released in January, and then like in March, they will have a new private version that rotates some of the stuff. So this is kind of, at least what they found as the best way to approach this.
Okay, this is interesting. Yeah, I've seen actually on one of your screenshots that you recently evaluated DeepSeek R1. So could you elaborate on the overall safety of using these models? Because that was one of the discussions, you know, when DeepSeek broke out.
Yes, that's a kind of interesting one also because one thing that also media often don't differentiate is that there are multiple versions of DeepSeek. So there is a version one that is online where you kind of DeepSeek is hosting the model and you're sending the prompt to them, and then this is, for example, why it was blocked in Italy. So in Italy, a couple of days, they immediately blocked the whole thing because they said, you're not processing the user data in a way that conforms with the data privacy regulations that we have in Italy. And by the way, this has nothing to do with EU Act. This is just Italy decided on a local government level, we are going to block it. But then you have the version that you download locally on your laptop. And like locally on your laptop, at least no one yet found that DeepSeek would like be sending your information somewhere else. This is not the case. I think the main challenge with DeepSeek in terms of security is DeepSeek is trained in a way that they try to make the model reason. So what does it mean is that it will essentially not just answer your question, but it will try to come up with like all the steps it used to come up with the answer. And this is a huge security problem because many of the things are essentially in that part of reasoning, you can be leaking a lot of the information, and there is no way to turn it off. Okay. So, like a lot of the benchmarks would, for example, be like, okay, this is a private information. Like this is the email of this colleague of my company, or like, I don't know, like Jonas, what is your email? And it will start reasoning, like, this is why I cannot give it to you, but maybe this is the email, but I will not tell it to you, but it already kind of leaked it in the response.
Okay. This is actually interesting. I never thought about it like that. For a small company, the new to AI Act that created low risk model, what is the rough estimate on creating documents on proving that this model complies with EU AI Act for small model?
I think it's, in general, it's not about the size. So what the EU AI Act has, I mean, it has a size restriction, but that size is like pretty much even OpenAI with the big models are like below that size. So it's like set really, really high. So for like most of the practical systems, it's not about the size, it's about kind of which risk category does the model fall into. And this is what the EU has. It has this risk-based approach. So there are things that are prohibited completely. Like you cannot do like tracking people in the workplace and like checking what they are doing and like what is their emotional state. And then there are things that are high risk. So if it's a high risk, then you have essentially more obligations, including are you actually developing the model or are you just deploying the model? So I think for the deployment, it's still new. So I think that's part of the challenge. Like we are still at the level like even us. So we are figuring out what to do it the first time. So that's why many of these are kind of very, I mean, it took us, for the DeepSeek, for example, the analysis took 1 week. for the new model. So for us, internally, it took us 1 week to analyze a new model. So if you want a number, let's say 1 week.
Yep. Are there specific aspects in AI that you consider especially difficult to comply with, both in principle and in practice, and based on the benchmarks? Is there something that everybody's missing, you know?
I think the main challenge in many of these is ultimately like where the threshold is. So I even showed like one of the toxicity and harmfulness. Like everybody was 96+%. But this is also one of the things that UX doesn't tell you, like is 96% good or is it bad? Like if I have a model that like 4% of the prompts is still going to like say something inappropriate and biased and discriminatory, that's probably still not very good. So I think this is exactly the challenge between what do I need to do to comply and what is good enough for me to deploy. So to me, I think the most challenging ones typically are the ones that deal with humans. And this is also what we've seen. So for example, things like, do you have enough human oversight? And what does it mean? And like, how do you check that people are using the system in the way they are using? So one concrete example would be like when we talk with some of the banks, for example, in Switzerland, like one of the things that is, for example, prohibited by the legal teams of the banks is, well, if I have a policy so if you get onboarded to a bank, you have like a bunch of policies you have to read and comply with. I cannot take the policy and give it to the system and tell it, please summarize the policy to tell me what to do. Like it's not an allowed use of the system. But now how do you check it in practice?
Oh yeah, that's right. So you basically like give the documents to me, and if I run it through the ChatGPT, that's technically prohibited, but I will probably for the first time ever understand what what the rules are, right?
Yeah.
Yeah, but so how the control questions for the tests were created? Were they provided externally or by your company?
So it's a combination. So most of them were external, and maybe I didn't mention it. So specifically for this project that is open source, we did it in collaboration with academia. So we did it in collaboration with ETH Zurich. We did it in collaboration with Insight, that's a research institute in Bulgaria. So the mapping was essentially based on what are the latest benchmarks that researchers or anybody really published that are publicly available. What does that benchmark do? Is that benchmark kind of reasonable? Does it have enough quality? And does it map to some of the requirements from the EU Act? So I think 95% are essentially public benchmarks. 5% are those that we had to create ourselves because they don't exist. So there was a requirement, and then you look around and this doesn't exist. And maybe kind of follow up on this question, when you go to specific industries like banking, the main requirement there is like, okay, what is a benchmark relevant for banking? Because many of these benchmarks are kind of very general purpose, like, oh, I'm testing general knowledge about like who is the president of the US and like general reasoning things, but this might not be aligned if you want to do like analyze or internal data for like investment patterns and summarization and stuff like this.
Okay, yeah. From our experience, big companies can be very afraid of generative AI. Does scoring well in the rules help getting generated AI-powered products to enterprises?
Not something that we've seen. So, I mean, I think that's this kind of question, like, by now, I mean, we're not trying to encourage people to use Gen AI, like that's not the goal of the benchmark. We are also not trying to scare people from using benchmark. We are just trying to say this is kind of, now you have the right tools to make informed decisions. From what I've seen, I have not seen a company who would be doing it like this. I think typically often this now, at least these days, this comes kind of top down. Yeah. Like the management of the company just decides like, getting into AI is a strategic thing for the company to remain competitive, and let's find ways how to do it in a safe way. And one of them is to have a kind of not just take a random model from the internet and deploy it, but actually think about what are the consequences, both technical, legal, ethical, and others.
Yeah, that's my experience as well. That that you deploy first and ask questions later. So, do the newer models consistently perform overall better on your metrics? Is there any convergence trend that you can identify?
In general, they do. Yes, yes. I mean, this is also when we spoke with ML Commons, like often this is how you in some way drive innovation, right? Like if you make it clear, and this is not by means like, okay, I see what the benchmark is and I like overfit on it and then I'm better. Like more in terms of these are the important aspects, and now if companies start taking it into account where they develop the models, fine-tune the models, you would definitely expect this to go higher. It's not always the case. So this was, for example, also the case for DeepSeek, because what they did, they have these two models. One was this big one, R1, that was like 480 billion parameters. But then they also had the smaller ones, which was, let's take, for example, model from Meta, and then DeepSeek fine-tuned that model. And when they did that, actually things got worse. For some of the, especially for the security, some of the toxicity went down. Some of the others went up. So it was kind of trade-off.
Yeah. What was the most problematic part of AI Act to implement? I think this is basically, this pertains to your model or, benchmark.
I think the main aspects are like one is around the copyright. That's definitely very challenging. Because I mean, it's also one of the interesting ones. It's like you have this black box approach to check if something else did something wrong, and there are other ways to do it, but because you don't have access, you have to find other ways. Yeah. And it's not only text. Like these days, many of these models are multimodal. So, for example, we were talking with the ICMP. This is the representation of like all the how is this called? The music industry. So all the authors, not the recording companies, but the individual artists. So the individual artists that have rights to their work. And now it's like, how do I check if I have a database of like 50 million songs from last 50 years that this was trained? The same thing for artists that are just painting. So that's the challenge of like, you can have a technical check to check, for example, like, was it trained on this data? But there is like millions of documents you can check. Like how to pick which document you're actually checking. That's challenging. And I think the other one is ultimately bias and discrimination. That's a big topic where, again, on one hand is like, how do I technically check it? And the other one is like, what does it even mean? Like, what are the attributes of the bias that I should consider? Yeah. Because often for bias, things are like, oh, there is a protected attribute, like race or sex or gender, and I have an attribute and I can check some performance of the model with respect to that attribute. Now, Gen AI, I have like lots of PDFs that I train the model. Like, what does it mean, or like a race of a PDF? Like, I have to understand the text. I have to extract, like, does the text talk about men or women? Like, in what context? So that's like a lot of complexity around this.
Yeah, and how do you interpret the score? That's another problem, whether that's bad or good. So. Yeah, that's actually the next question. How difficult is the interpretation of scores, and can this be automated? Yeah, can we put AI above the AI so that we don't even have to read the scores?
Yes, so it's definitely difficult. I would say the state of the art in this area is essentially relative comparison, which is now there's like 5 big providers of AI models. There are like lots of like open source models that exist. So essentially the goal is to say, let's pick a couple of best open source models that exist as a baseline. So again, could be bias, could be something else. And then let's score relative to that baseline to essentially see kind of how well do I fare. And then if I see like I'm much better, that's good. If I see I'm much worse, then clearly like, even if I take this open source model, I'm good. So it's kind of a combination of having it relative. I think that's what we can do best at this point. Yeah,
that's what we actually do with benchmarking in biometrics as well. That that you have like scores for all the different providers, and you see how relatively you fare, because even if the results don't look like that's promising, they can still be like the best in the world.
Yeah, and maybe just to follow up on that, and that's also the difference between assessment and risk mitigation. Because the assessment tells you this is your score, this is how other systems compare, this is what you can expect when you deploy it. And then the risk part says, okay, is this acceptable? Or do I need to do something to like, do I need to block this feature? Do I need to put some other guardrails on top to kind of put it down because it's too high? Like we had with the fingerprinting, like is it 15% good or bad? Well, depends, right? That's the answer.
Yeah. If you do it in financial industry, yeah, that's definitely not good. So outside of lack of specificity or details, have you encountered any large blind spots of the AI Act that should be addressed?
Good question. I mean, it doesn't tell you what to do. I mean, that's the biggest blind spot. And that's why there is a code of practice now that tries to kind of concretize it. And I think the large blind spot, unfortunately, and this kind of goes back to kind of European Union, is how the whole thing was created. Because the whole thing was created by politicians. And as you can imagine, there was like a lot of negotiations, not at the level of kind of technical or like, I don't want to say anything bad, but it was made by politicians. So I think that's kind of.
Yeah, I understand. There's a gap.
Yes, I mean, probably the most obvious thing was like when they were deciding, for example, like when it comes in practice, it was like, oh, it should be in 4 years, it should be in 2, okay, let's do 3. And let's agree. And it's like, okay. That's one way to do it.
That's why we have you here, because everybody sort of wants to be prepared and nobody clearly knows why. So this is, we mentioned, okay, this is for you actually, Igor. Fingerprints, have you considered liveliness detection, how to prevent users from providing a picture of a decoy or a fake finger?
Well, thank you. Well, this is actually a different kind of issue, and we have another layer of security where we develop specific models for this. So we have a liveness detection model, and it can do all kinds of presentation attack detection, and it also understands different modalities. So we don't have to train the model specifically for fingers, because it understands that, I don't know, you are holding a tablet or having it printed on a sheet of paper. So yes, we do have that.
Yeah, and it was for the at the beginning it was created for actually facial attack detection. So when you do like a photograph of a face or a mask of a face, but yeah, it works for fingers as well. So that's something. I hope it's not a risk or something like that for AI Act, but we will see. This one is for you, Pavol. How did you create the inputs for the Bulgarian model? It's probably pointing to the fact that it's in Cyrillics.
This is not a problem. I mean, these models are multilingual, so there is a tokenizer, and the tokenizer just tokenizes everything, and then it works. Typically, the bigger problem is the language translation. So naturally, you don't want to take like benchmarking English, like run it through Google Translate, get something out and say, oh, now I have a new benchmark. We haven't done this, but this is, for example, also what MLCon was done. They released the French version of their benchmark last week, and it's a manual process. So it's a combination of I can do like automatic translation, but there is a human who would kind of look at it and approve or like fix the mistakes. Plus, they added essentially a specific part of the test set that is now specific to, in their case, French, or it could be Bulgarian, that is, for example, things that are specific to the language. Could be stereotypes, like phrases, things like this, that like Google Translate cannot really.
Yeah, so and you would need sort of something like this for like probably each new language, right?
Yes. So that's definitely a challenging part. You cannot, just go
because I can imagine like the big languages like English, Spanish, and French. You know, they probably have like enough data for that. But once we're talking about, I don't know, Bulgarian, Slovak, that's quite different. Is the model coming across as human-like rather than a tool, a part of the safety assessment, especially with the trend of humans becoming attached to LLMs?
Yes and no. So if you read the UI Act, there is a specific part that talks about transparency, which means the deployers and the deployers of the systems have obligation to make it very explicit that this is an AI system. So if I go and I go to do like a chatbot, or I go to the contact person, and then it has literally, before even I've read anything, it has to tell me I'm a chatbot, I'm here to help you, or whatever that is. And it has, and then there are specific requirements in terms of accessibility that link to other standards from before. Like it has to be like if I have I don't know, like some disability, it has to be at least into like text and audio, or text and vision, and stuff like this. But there is no requirement in the kind of type of interaction. So this kind of human-like, this would not be something that React would try to restrict. So like whether the tool is emotional, or like whether it connects, like this is, they are not considering this aspect.
Thank you. What key quality performance metrics, such as response confidence level, would you recommend monitoring after generative AI deployment? I think this is the question from a practical company. So, what would you recommend once you deploy the generative AI model?
I think there are a couple of metrics. I mean, ones are related to the kind of how good the system helps users to do their work. And these are typically these kind of things, like you have this thumbs up, thumbs down, that people can explicitly give feedback, and you have also indirect ways to collect feedback, like the user. How can you indirectly estimate whether the user actually achieved what they wanted to do or not? And then there are kind of, the second step is kind of more low level. So for example, many of these generic deployments now would be so-called this RAG system, retrieval augmented kind of retrieval, where you have some internal knowledge base that is trying to retrieve some documents. Then you can start checking like how well am I retrieving the documents, how accurate am I, and so on. And the third one is kind of pure kind of performance. So like what is the latency of the system? Like how many users are using it? Is the system kind of have too many things, too many people running at the same time, and should I scale it? Things like this.
Yeah. It sounds like it came from a financial institution, because this is like the main deployment for the. And we have a last question for Igor. So, did you consider actually doing it the contactless fingerprints the other way around, from modeling it from 2D fingerprint to create 3D model?
Actually, we did not, but thinking about how much information is there, then I would say our way is more favorable, because if you start with a 2D impression, then you have already gave up too much information. So, I guess.
Okay, so thank you very much. I don't see we have any other questions, so I would like to thank Pavol and Igor for their participation. I'm wishing you good luck with implementing all the stuff that AIX wants from you. I want to thank Kinit, Innovatrics, and the Spot for once again holding this meeting. And we will see you in, I think, 2 months, and we will be streaming from Brno. So thank you and goodbye. And don't forget to actually check out aiawards.sk and enroll yourself. You still have 2 more weeks until the end of February. So thank you and good night.